Okey, baik. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Dan selamat pagi semua para pelajar, sahabat-sahabat daripada Jabatan Kejuruteraan Elektrik. Okey. Dan juga speakers kita, okey, Cik Muhammad Ahmad Marwan bin Muhammad Dahlan. Okey. Okey, bagi memberkati majlis kita pada pagi ini, okey, bersama-sama kita, semua pelajar, kita mulakan dengan bacaan Ummul Kitab Al-Fatihah. Baik, alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya wal mursalin wa ala alihi wasahbihi ajmain. Okey, alhamdulillah pada pagi yang mulia ini, okey, semua para pelajar tahun 2, okey, pelajar tahun 2 di DAE dapat bersama-sama berkumpul pada pagi ini, okey, untuk kita menambah ilmu, okey, mendengar mungkin satu sharing session, okey, satu sharing session daripada pihak industri, okey. Biasanya kalau kita dengar dalam kuliah, okey, kita dengar sharing session daripada pihak pensyarah sahaja. So hari ini kita sangat bertuah, okey, untuk program DAE32603 Communication Engineering, okey. Kita boleh berkongsi idea, okey, dengan pihak industri. Okey, saya perkenalkan pihak industri kita iaitu Encik Ahmad Marwan bin Muhammad Dahlan. Okey, terima kasih kepada Encik Ahmad Marwan, okey, yang sudi bersama-sama kita pagi ini untuk kita share, untuk sharing knowledge pada para pelajar. Okey, yang mana kita tahu para pelajar program diploma ini masih lagi di peringkat awalan. Okey, untuk peringkat awalan untuk dalam dia punya career path dia lah. Okey, mungkin selepas ini para pelajar akan pergi sambung belajar peringkat degree, master dan seterusnya. Okey, untuk pengetahuan Encik Muhammad Marwan, okey, program Diploma Kejuruteraan Elektrik ini adalah satu-satunya program diploma berkaitan elektrik di UTHM. Okey, sebelum tu saya kenalkanlah di UTHM. Di UTHM ni ada dua kampus, okey, satu kampus di Paya Raja dan satu lagi kampus Pagoh, yang mana pusat pengajian diploma ni terletak di kampus Pagoh lah. So pusat pengajian diploma ni kita centralize program-program diploma yang ada di sini. Terdapat lebih kurang 6 program, okey, electrical, mechanical, awam dan juga IT, dan juga kimia dan juga sains gunaan. Okey, jadi untuk program elektrik ini saja. So pelajar-pelajar yang ada di sini adalah pelajar program tahun akhir, lebih kurang tahun akhir lah. Okey, selepas ini mereka akan pergi ke latihan industri dan selepas itu mungkin mereka akan bekerja ataupun sambung belajar lah. Okay. Bersama-sama kita juga pada pagi ini juga kita ada beberapa orang pensyarah daripada Jabatan Kejuruteraan Elektrik, iaitu Cik Muhammad Syukri, dan juga kita punya timbalan dekan Hayat Awal Pelajar lah, Puan Haja Ziana. Okay. Okay, sebelum tu saya perkenalkan Cik Ahmad Marwan. Okay. Cik Ahmad Marwan ni mempunyai banyak pengalaman okey, dalam bidang telekomunikasi. Okey, dia dah bekerja dengan syarikat Huawei, Telekom Malaysia, okey, dan sekarang bekerja under OCK Malaysia, okey, satu syarikat konsultan, okey, yang mana beliau mempunyai pengalaman lebih kurang dalam lebih daripada 10 tahun, okey, dalam bidang radio access network architecture, planning dan juga optimizations, okey. Dan juga beliau dah membuat satu planning, okey, berkaitan dengan telecommunication di banyak negara di seluruh Asia Pasifik inilah. Okey. Okey, tanpa membuang masa, okey. Okey, tanpa membuang masa, so insya-Allah lah kita akan ada sharing session ni lebih kurang dalam 40 to 40 minutes, okey. And then kita akan ada sesi soal jawab. Okey, mungkin ada pelajar ataupun staff nak berkongsi soalan ataupun berkongsi idea dan sebagainya, boleh kemukakan. Okey, kalau tak nak bertanya secara direct, boleh boleh juga type di bahagian ruangan komen, saya akan bacakan. Kemudian pelajar juga akan ada mungkin ada sedikit quiz lah, so ada refleksi sedikit tentang apa yang disampaikan oleh Encik Ahmad Marwan. Okay, so quiz tu akan diberikan pada bila-bila masa. Okay, so quiz tu semua berkaitan dengan apa yang akan dikongsikan lah. Okay, tak susah pun. Okay, sangat-sangat mudah. Okay, so Cik Marwan nak bagi markah free kepada kamu semua. Okay, okay, so para pelajar mungkin mungkin boleh buka kamera lah, buka kamera dan juga tapi tanpa buka mikrofon, mungkin boleh buka kamera untuk kita lebih orang kata lebih dekat lah antara speakers dan juga audience. Okay, so tanpa membuang masa, saya serahkan kepada Encik Ahmad Marwan, untuk sharing apa yang dia berkaitan dengan teknologi 5G ni lah. Okay, silakan Cik Ahmad Marwan.
Okay, terima kasih Dr. Faizal. Saya macam Dr. Faizal introduce tadi, saya Ahmad Marwan daripada sekarang ni kerja dengan OCK Malaysia sebagai Radio Access Network Consultant. Jadi saya dengan Dr. Faizal ni dah kenal lama lah daripada belajar lagi. So mungkin any question nanti kita sampai hujung nanti kita ni. So saya plan lecture ni mungkin saya mix sikit lah bahasa Melayu, bahasa Inggeris, because most of the terms tu dalam bahasa Inggeris. Jadi kalau kita cakap bahasa Melayu nanti kadang-kadang dia tak match. So okay. And then for this lecture, I will focus more on the industry, I will try to touch on the current progress in the 5G networks, the general knowledge, rather than kita masuk teori, too deep into teori sampai calculation nanti, itu nanti panjanglah lecturenya. Tak cukup lah untuk 40 minit. Jadi just an update and sharing untuk semua pelajar-pelajar. I hope you guys can gain something from this session. Alright, so let's start with the lecture. Okay, first question biasa orang tanya, what is 5G? So before we go into 5G in detail, we have to know first, what is 5G? 5G ni we can say is the next evolution of the mobile network. So right now we have 2G, we call it GSM or CDMA. We have 3G, kita panggil dia UMTS. We have 4G, kita panggil LTE. Dan sekarang kita ada 5G, kita panggil NR. So untuk ramai orang tanya, so kenapa kita nak buat 5G? Kita sekarang ni dah ada fixed network, dah laju dah. For example macam Unify, time broadband, very fast dia punya throughput. Boleh pergi up to gigabytes per user pun and very stable. Tapi the only downside is that fixed network tu, the nama dia tu pun dah explain lah, is fixed. Dia tak boleh pergi mana-mana. Dekat rumah, then kita connect wifi, then that's it. Kalau kita keluar rumah, dah tak ada dalam wifi. So our connection is lost. So that's where mobile network comes in. So mobile network ni, most of us familiar ni macam Maxis, Celcom, Digi, U-Mobile. So those are the mobile networks lah yang kita touch hari ni. So apa beza dia ni 5G ni with the previous technologies? So kalau kita tengok 2G, 3G ni ramai pengguna dia adalah user. So kalau kita tengok dekat sini, there's a pointer. So kalau kita tengok dekat sini, 2G, 3G is mostly 2C. 2C means to consumer. Kita lah, the users, the daily users, subscribers, kita biasa pakai dekat sini. That is for 3G and 2G. There's no other industry or other connections yang happen. So once kita masuk into 4G, then our internet speed pun is faster and everything. So we use it for consumer and also to H, meaning to the home. So in 4G we start to see fixed wireless access. So sometimes dekat rumah kita tu fiber tak sampai lagi. So call TM kata, oh we cannot pasang fiber in your home. There's no Unify cannot pasang because there's no fiber. So this is 2H lah. We use 4G technology to provide internet to your home wirelessly rather than using fiber. Alright. So bila masuk 5G, apa lagi yang kita nak cover? We have to consumer, to home, and to B. To B ni apa pula? To B ni is for business. So for business ni meaning TV station boleh pakai, hospital boleh pakai, and some power company pun boleh pakai. Example in Malaysia, kita ada TNB. TNB sekarang dia pakai smart meter. Smart meter ni dia without having the staff go and read the meter every month and then give you the bill, dia buat ni pakai wireless je, pakai the smart meter lah. So they just send the data over internet. So right now even 4G they're doing that, but in 5G you will be able to cover more and more users and at the better reliability lah. Okay, so dia dekat dalam the evolution ni ada macam-macam lah dari teknologi dia. Ada TDD, ada FDD. TDD ni maksud dia time division duplex, and FDD is frequency division duplex. So this one is a technology that we use lah to make use of the spectrum that we have. Okay, let's go to the next one. So this one is a very important, very key takeaway for 5G. So 5G ni dia mostly covers 3 system. We have EMBB, we have URLLC, we have MMTC. So each of these is what define 5G actually, the system. So EMBB means enhanced mobile broadband. Meaning right now you're using your internet is on your phone is broadband biasa, broadband yang LTE lah. So you can get maybe up to 100 Mbps, 200 Mbps in a very good situation and there's no one else using. So once there are people using, then you get maybe lowest throughput, maybe 20 Mbps, something like that. So with EMBB, enhanced mobile broadband, you can get the throughput that the ones that been shown in the promotional for 5G, 1 Gbps, maybe 2 Gbps, those kind of speed. So this is enhanced mobile broadband. So the next one new in mobile network in 5G is URLC, ultra reliable low latency communication. So what does this mean? Meaning the communication in 5G is very, very reliable. Let's say it's very, what you call that, robust, and you can make sure the data sends and comes at a very secure rate. And it is also low latency, very low latency. So sekarang if some of you guys playing, especially the boys lah, if you play the games, mobile games, let's say PUBG ke, Mobile Legend ke, those games, let's see, you always concerned about your latency. Here latency means similar to ping. Okay, so if you are having very high ping, meaning your packet or your data sent to the server will take a lot of time. So meaning by the time, example, you play PUBG, by the time you press shoot, you shoot the people, and then it will delay. There's a lot of delay, and then you miss the shot. Nak dapat headshot, jadi dapat tembak rumput je. So something like that lah. So with ultra low latency, you can get maybe 1 millisecond ping. This is what we've tested. In actual testing, right now we have received around 4 milliseconds. So this application is very important, especially for real-time communication. Example, ada VR and so on. This one I'll go through later. All right, so that's low latency. So the next one we have is MMTC. MMTC means massive machine-to-machine communication. So what does this mean? Example, nowadays, everything is IoT. IoT means Internet of Things. Semua device kita, even mesin basuh, peti sejuk, everything is connected through internet. So, and everything needs to communicate and send data. So, and then they send data, they don't send to user. Example, let's take example, ni lah, peti sejuk lah. They want to send some data to the supermarket, those groceries that you need to buy. So it's machine-to-machine communication. So this one also is being done in 4G, in 3G, there's this communication. But what is the difference in 5G? So the advantage in 5G is that machine-to-machine communication previously is limited to 100,000 or maybe 200,000 devices in a square kilometer. So dalam satu kawasan tu tak banyak yang dia boleh cover. But then when we move forward, when we are advancing our community, our lifestyle, there will be more and more connected devices. So in 5G, we can cover up to 1 million devices in square kilometers, right? By the way, kalau my voice is not that loud or anything, just let me know, yeah. So with these three systems, EMBB, URLC, MMTC, what can we do? So here the example just now I want to say VR is actually a combination of URLC and EMBB, meaning you need a very low latency, low delay, and also a very good throughput speed. So with this we can do VR. Example. So VR ni, if you ever tried wearing the goggles, if the vision or there's a delay in your visual, the goggle is delayed. When you twist your head and then the image is slightly delayed, maybe more than 200 milliseconds, then you will get dizziness. So you'll be feel very dizzy, nausea and everything. So it's important to have URLC and EMBB. So EMBB is to make sure the picture quality is good lah. So now we are talking about 4K picture in the goggles and everything. So the next one is MMTC and URLC. What you can do, because of the reliability and the low latency and the machine-to-machine communication, we can use this for harmonized communication and sensing. So for example is V2X. V2X means vehicle to X, anything. X is anything. So example sekarang ada Tesla car, they're using autopilot, so they need to communicate with each other. So this also, right now there's a lot of levels of autopilot, level 1, 2, 3, 4, 5. So we go through next one. And the next one is MMTC and EMBB, is for the uplink centric broadband communication. So you can use for something like in the manufacturing, you need to upload a lot of data. Example, you need to stream video upwards to the internet or to the other side. So this is the utilization. All right. So again, next question. Why do we need 5G? Why 5G? Why don't we use the current one that we have? So let's see what's happening in our life right now. So this is actually this slide is before the pandemic. Even now, after the pandemic, you can add in video call or video conference like we're having now as part of the lifestyle that we have now. So main requirements or why we are developing 5G is because of our lifestyle. So personal, we have a lot of use of internet today. In the home, we use a lot of Netflix, a lot of entertainment. The cars also start to be connected. In the industry also, you're going to be connected. Even drones and surveillance systems now, you can monitor it by using internet. So this is the requirements comes from here. So we can take example, if you live one day without your phone or without internet, you have your phone but no internet. So your life will be slightly harder lah. No WhatsApp, no everything, no GPS, no Waze. So that's the importance. Our lifestyle is changing. Compared to the past 10 years, we are using a lot of internet and connectivity. All right. So this is another thing. Just now I mentioned VR. So right now VR is gaining traction or gaining interest from the masses, from the community, from the people. So started from 2014 VR to start to pick up back, and then now we are doing 5G. We expect 5G to further catalyze the advancement of VR. So this is the target, actually the ideal 1 gigabit per second bandwidth in less than 10 millisecond latency. So this is the target for VR. So requirement 2, we hope with 5G that 5G can fulfill. So this VR is definitely getting traction. As example for the game Half-Life Alyx. So this one, there's a lot of players playing. So we can see VR is catching up. It's going to be the next thing. The funny thing with the mobile technology is that we can just estimate apa yang akan jadi the main use of the technology. For example, 2G dulu, we know it's used for only SMS and for voice call. And masuk 3G, kita expect mungkin jadi video call because 3G introduced video call and everything. But in the end, 3G not really into video streaming or video call or anything. So they more to voice call and just web surfing. And once kita masuk 4G, we already expected maybe something even more. But in the end, what people use 4G more is for video streaming, YouTube, content viewing, and streaming lah, video call in 4G. So 5G ni right now we are trying to we try to predict the usage of 5G, but which one will actually take up, which one will be the main usage, we're yet to see. So now we can just we can just estimate something. All right. So the next one is on the V2X, or the what, as I mentioned just now, Tesla vehicle to anything scenario after 2025. So right now we are in the phase maybe phase 2 because this autonomous driving, there's multiple level from level 0 up to level 5. So in level 0 there's no autonomous driving. This is just the human interaction, just a human orang lah bawa kereta. So this one not really required any technology communication, maybe just 2G, 3G, 4G for GPS and such. So in level 1, level 2 is assisted partial autonomous driving. So dekat sini vehicle dah start to collaborate on the road. So they start to send in data to the server, and the server try to compile data and such. So this one they use LTE and V2X through the LTE network they can do this. So level 3 is conditional automation, meaning you can let the car to drive in certain situation. So this one we may use the 5G eMBB, the one I mentioned before, the high bandwidth, and also the V2X. So the last or the ultimate goal is that when you reach to level 4, level 5, advanced or full automation. With this, actually, you just expect the car drive by itself. You don't have to drive it to the highway and then baru start autopilot. You can just go in your car from your home and then start the autopilot. So this one actually requires eMBB. You have to have the low latency and very reliable network in 5G, and also the V2X communication. So this is the progress that we are doing. The industry in the autonomous driving is aiming for this, and mobile communication will be assisting to make sure the communication is very reliable and with low latency. Okay, so let's go to the...
Sorry, Mr. Marwan. Okay. Maybe so kalau kita lihat kat sini kita punya scenario after 2025, okay, in 5G. So is it possible 2025 tu akan berlaku di Malaysia untuk teknologi 5G ni?
The 2025 ni more to international target for the one that we have. Because dekat Malaysia ni right now we are in 2021, Tesla officially pun tak sampai lagi, so we might be a bit lagging. But in generally, but sooner or later this one will come lah, because the vehicles pun kita start nampak other manufacturers, Volvo, BM ke Audi ke, they will start to do this. Even X50, X70 pun dah start ada some level of autonomous driving. So assisted driving pun dah ada, but we are surely moving towards this. Dr. Faizal nak beli kereta ke ni?
Okay, so kalau di Malaysia ada, bolehlah beli kot.
Itulah.
Okay, so maybe somebody atau student jika ada perkara-perkara yang nak bertanya, okay, mungkin it's okay kalau kita interrupt Encik Marwan.
Boleh.
Okay,
Interrupt je.
so
Assalamualaikum, Marwan. Saya nak tanya, macam mana dari segi kos untuk katakanlah nanti untuk kerajaan bawa 5G ni ke Malaysia? Daripada segi kos.
Of course, nak bawa 5G. I think that one I'll touch later a bit lah dekat dalam slide ni.
Okay.
Ni baru introduction aja, tak sampai lagi. Nanti I'll touch on that. I keep that in mind. Okay. Ada question lagi tak? I think the next session will be a bit heavy sikit lah. Yang ni baru introduction dia. So the next one is the more detail sikit on 5G. Alright, if tak ada, then I continue. So we continue with the 5G development. So 5G ni firstly is introduced in 3GPP. If you are familiar with the mobile network, 3GPP ni yang control the global standard for mobile network, starting from 3G lah. Masa 2G tu they're not really ada standard globalized, they ada multiple standard. In 3G they start to have some standard, and then in 4G and 5G we are using 3GPP standards. So 3GPP ni start from the release 15 in 2018. Release 15 2018, they start to talk about 5G. They start to release on 5G. So the first one they release is NSA. NSA means non-standalone, meaning this 5G requires 4G to work. We call it anchoring, or they required 4G for signaling and then 5G for data. And then after that, at the end of 2018, they come up with the SA, standalone network, meaning 5G can just be 5G without requiring 4G. So in release 15, they focus on the EMBB, the mobile broadband, enhanced mobile broadband for better throughput, for better user experience. So and then mid 2018, 2019, they released the release 16. So in release 16, they talk more about enhanced mobile broadband and also low latency communication. So this is where they start to develop one by one the systems that we talked about in previous slides. So in 2020 Q2, they start to have release 17, which is in the works until right now. This is focused adding on to MMTC, machine-to-machine communication, while improving EMBB and also URLLC. So release 17 is a bit delayed because of the pandemic. Suppose they release, they finalize or they come up with the standard last year, if I'm not mistaken. But due to the pandemic, they slightly delayed. All right. So these are the important name lah, 3GPP for this industry. Okay, so in 5G, it's a mobile network, so we have to talk about the spectrum. Okay, so I think you guys already know what is spectrum, which is the air or the air interface yang available in Indonesia or available in the world. So example, biasa kalau kita dengar radio, you maybe buka hits.fm tu 92.9 MHz, itu dia punya frekuensi dekat bawah sini, 90 MHz. So for mobile, we are using maybe from 700 or 600 MHz up to biasanya sampai 2.6 GHz. This is currently 4G we use up to here. But in 5G, we start to use the higher frequency. We use C-band, 4.9 GHz, 6 GHz for the sub-6 category. We call it sub-6 GHz category. And also we have millimeter wave, which is in the very high frequency, 26 to 100 GHz. This one will provide low latency and very high bandwidth. So kita tengok ni some people maybe if you heard outside ada orang buat bising, ada orang especially in Europe lah, they said 5G is transmitting coronavirus lah, dia kata 5G is what you call that, is killing people lah. So we have to understand, we as the technical people, we as the engineers, we have to understand, we have to be informed. The spectrum, even though it's very wide, agree you have some, even if you have microwave, guna untuk masak makanan tu pun, is actually guna this, not these frequencies, is actually using the wireless technology, wireless spectrum. But there are few types of wireless spectrum. They are non-ionizing and also ionizing frequencies or band. So the ones that we use for mobile communication is non-ionizing. Non-ionizing means it will not make any changes to your cell or your apa nama ni, your cellular structure lah, your body. So of course there won't be any cancer. So you should not be causing any cancers and such. So this one, and then one more thing is that 5G is not just start to use this bandwidth. Before this, these bandwidths are already being used by other operations. Meaning it's not just when you have 5G, then this band starts to transmit, start to use this band with transmitting something. No, actually these bands are being used by satellite communication previously, and also some microwave links. So it's already in being transmitted for the past many years. So it's nothing new actually. Nothing new in terms of spectrum. So okay. So what is the difference? We have so many spectrums here. You have 700, which is sub 3 gigahertz. We have sub 6 gigahertz, and we have millimeter wave. So the lower latency propagation here, 3 gigahertz, you can go further. Meaning when you have your base station, and then or your transmitter, you can transmit the signal lebih jauh. So with the sub 6 gigahertz, you can transmit shorter. With millimeter wave, is very short. So ini, but the difference is that at the low latency, the bandwidth is very small. So the pipeline or jalan tu kecil, walaupun dia boleh pergi jauh, jalan dia kecil. So kalau yang tengah-tengah ni jalan dia medium, and dia boleh pergi medium distance, and millimeter wave is very big pipeline, very big lane, tapi can go very short. So why? I think ni nanti Dr. Faizal mungkin dah ajar kot. Free space equation. Free space equation, the power you receive is equals to the power you transmit times the gain of the antenna at the receiver and the antenna at the transmitter over the frequency. So meaning power yang you receive dekat phone tu is inversely proportional with your frequency. So kalau frequency tu tinggi, lagi rendah lah power dapat. Kalau base station tu sama jauh. So that's why we use multiple bandwidth. So we can use different scenarios. Because in most of the case, as we mentioned, we want the high throughput. Nak laju, tapi we can build this one. But if we build this one, we have to build a lot because dia punya coverage kecil. So cost dia tinggi, macam Cik Lokman cakap tadi tu. Okay, so let's go bawah ni sikit. So kita ada juga some teknologi macam kita ni jauh. Example yang ni boleh cover distance dekat. Yang ni boleh cover distance dia jauh. So apa yang limitkan kita punya signal phone tu sebenarnya? Okay, daripada base station kita ke bawah, ke phone, kita ada transmitter dekat base station tu. Transmitter tu the power is higher compared to the phone power. Kenapa phone power tu kecil? Kalau phone power tu besar, bateri tu tahan sejam je lah. So to make sure the battery can last and also to reduce the impact of radiation near the human body, dia pakai dekat dengan very lower power lah for the phone to base station communication. So base station to phone kita panggil dia downlink. So sebab dia pergi ke bawah Lepas tu kalau daripada phone ke base station panggil dia uplink. So dekat situ tapi kita ada multiple band ni, yang limitkan kita adalah dekat uplink sebab phone kita boleh transmit power rendah saja. So kalau dekat dengan base station tu power dia besar sikit. So downlink tak ada isu. Jadi kalau macam tu, apa yang kita boleh gunakan dengan information yang kita ada ni, dengan kita tahu the coverage of this low frequency, medium frequency and high frequency, and also with the power transmit and the uplink and downlink limitation. So kita boleh buat, since most of the user are using the throughput in the downlink. Biasa kita pun stream video apa semua dekat downlink. So we require a large bandwidth in the downlink. So we can use this C-band, we can use the MM wave for the downlink. Pipe jalan besar, so kita boleh download data laju daripada internet. Tapi untuk upload, in normal case, kita tak pakai very high upload. Biasanya kita tak adalah kita stream 4K unless you are YouTube content provider, you stream live, that one you need to use a high uplink as well. Tapi most of the time normal users, kita download je banyak, upload tu sikit je lah. Just acknowledgement message or just a normal communication, not very high requirement. So for downlink, as I mentioned, we can use this large bandwidth, and for the uplink, we can use the smaller bandwidth. So downlink dia lalu jalan lain, uplink dia lalu jalan lain. So this is what we call uplink and downlink decoupling. Meaning uplink downlink dia guna frekuensi lain-lain. Kalau dia frekuensi yang sama, uplink downlink frekuensi sama, that one is the coupling. Uplink downlink coupling. So that's one of the ways that we try to improve the coverage of these higher frequencies, because the limitation is on the uplink kan. So uplink kita pakai ni coverage dia besar, and then downlink kita pakai ni. So we try to remove the limitation on the uplink for the higher frequency. And also, for this bandwidth, we have this, we call it aggregation technology. Aggregation means we can combine at the user you don't see, but at the phone they will combine the lane of this C-band maybe with the lane of this 2.6 GHz. Then you will get even more throughput. So this one depends lah. Even in 4G also we have this aggregation. In 4G, in your 4G phones, kalau you ada 4G phone, you tengok dekat your phone signal tu, you see 4G logo. But sometimes you will see 4G ada plus. So that plus means is having carrier aggregation. So ada pakai dua frekuensi lah. So your throughput should be better. Right. So again, this one is just a slide. I will not go very detail on this one. The spectrum yang I mentioned before this is key for 5G rollout, because macam I cakap tadi, the throughput and also our requirements is mostly on the throughput. We have very high requirement, but you cannot be designing a network with a very high requirement everywhere. Macam contoh kita cakap, katakanlah U-Mobile katakan, dia nak network dia, setiap user boleh dapat 200 Mbps, semua tempat. Dekat dalam kampung, dekat luar kampung, dekat pantai, dekat atas laut, semua dia nak 200 Mbps. So apa yang jadi macam tu? So kita letak banyak site. Bila kita letak banyak site, then cost dia akan jadi tinggi. Bila cost dia jadi tinggi, dia akan charge dekat dengan user. Kita lah kena bayar monthly, itu mahal. So kalau that, so we and also because they want the high throughput, they will use a higher bandwidth, a higher frequency. So C-band tu lah banyak, tapi coverage dia pendek. So kena banyak site. So and then that's why normally kita design tu is reasonable for the users, depend on the number of users tu berapa banyak, and also berapa what you call that throughput yang kita nak. Contoh sekarang ni Malaysia Communication and Multimedia Commission, MCMC, ataupun bahasa Melayu dia SKMM, Suruhanjaya Komunikasi dan Multimedia. Diorang sekarang ni set dalam 2.5 ataupun 5 Mbps minimum throughput download. So kita kena design based on that lah. So and then kalau requirement tu rendah and then user tak ramai, then we can use a lower bandwidth. So coverage dia besar, a lower spectrum. Example for 700 or 850 or 900 spectrum. So coverage dia besar, but they can cater for less user and throughput not so high. So that's how important spectrum is. And also is very important for the spectrum is on the power consumption satu, and also for the CA. Macam I mention tadi, dekat dalam 4G pun dah ada carrier aggregation, CA. Tapi carrier aggregation ni dia bukan any frequency can work with any frequency. Example 3.5 GHz spectrum, tiba-tiba you want to carry aggregation with 700 MHz example. That one is not being defined in the ITUR or the 3GPP. So dia banyaklah consideration dia when you selecting the spectrum, so that to make sure you can roll out 5G ni dengan cepat dan juga cost efficient. So this one if I go detail nanti dia banyak sangat. Okay, now let's go to the more that's what you call that very in 5G ni, apa yang the new architecture or the new advancement, the new technology. Macam tadi kita dah cakap MMTC, URLC dengan EMBB. Tapi how do we get that? How do we get the throughput very high? How do we get all this reliability and all that? So as I mentioned, now we are focusing in release 15 and release 16 is more on EMBB. So let's go on that. So right now, okay, tadi I mentioned C-band. C-band bandwidth is a spectrum. So C-band bandwidth spectrum ni for Malaysia, if you notice the announcement is 400 MHz the bandwidth. Tapi setiap satu carrier ataupun sub signal dia tu adalah 100 MHz, 10 MHz. So macam mana kita nak dapat speed laju ni dengan 100 MHz? So we can do this by using a technology, we call it massive Mimo. Mimo means multiple in, multiple out. So dekat sini ni the illustration dekat sini you can see this is example an antenna. So dekat dalam antenna ni ada multiple element. Ini Dr. Faizal punya expertise ni antenna ni. So dia design this last time. One of these similar to this. In the antenna there's multiple elements. Example ada multiple patches ataupun dia punya sub antenna dia. Antenna kecil-kecil dalam ni jadi antenna besar. So example for this one, maybe you can have 32 element or 64 element. So with this, the connection to your phone or to the user is not one antenna to one user. It's actually multiple antenna, smaller antenna connecting to the user. So dia ada multi-path effect. Ada some antenna ni, example this antenna, jalan dia lalu dekat sini, langgar this building, masuk antenna, masuk phone kita. Antenna sini pula mungkin lalu sini and then dia masuk dekat dengan phone kita. So the gain that you get or because there's a multiple lines in multiple input and multiple output, you can have a peak throughput for 100 MHz bandwidth of 5 gigabit per second for the whole user. So, sorry?
Ada soalan ke daripada pelajar? Tak ada Mungkin je. Tak apa, tak apa. Okay. Selepas ni mungkin boleh tanya lah
Boleh. Okay, so this one with using this antenna, multiple element juga, you can actually control the signal, the beam width, the beam direction of the antenna. So example, this one I dah lupa the basics or the theory behind this, but last time when we're studying with Dr. Faizal last time pun ada kita try buat Butler matrix, which we try to change the phases of the signal yang sampai to each of these element, then you can change the direction of the antenna. So physically, secara fizikalnya antenna tu maintain je. Dia tak you nak nampak dia coverage ke tepi, ke kanan, ke kiri, the antenna tak bergerak. Antenna tu duduk atas tower tu macam tu je, static. Tapi by using the phase difference and also the electrically, we can move the antenna direction. So sometimes you expect antenna facing like this, the coverage will be like this, but not necessarily. With Massive Mimo and also this antenna technology, the direction can be on the left, on the right, and also can be tuned accordingly. So now in 5G, this tuning, this phase difference is automatically. So they can create a narrow beam width for the users. So example, site tu coverage dia besar. Example kita ambil dekat Bukit Bintang lah contohnya, ada satu site dekat atas Loyat tu. So user dekat depan Loyat tu banyak, dekat Bukit Bintang ada, dekat dengan maybe Lot 10 ke, dekat dengan Sungai Wang Plaza ke. So macam mana dia nak cover all these users without moving the antenna? So the system can automatically shape the beam width to cover the users. So example, ada multiple users in one place, they make a beam to cover that one. So kalau ada single user tu, dia akan cover better lah. So with this, you can provide a better coverage. And also for some scenarios, ada building. Contoh bangunan tinggi lah, ada apartment. So antenna ni dekat bawah. Or antenna ni is try to cover the street and also the building yang dekat atas. So they can use this multiple beam to cover each users in each level. So this is some of the key technologies that we need to deploy lah. Massive Mimo is a must for 5G. Kalau tak ada, then we won't be getting the throughput that we want. Alright. Okay. So this is just now the one I mentioned, uplink and downlink decoupling. Sebab kita punya limitation is on the downlink. So example dia macam ni. So uplink ni we can use in a TDD system, time division duplex. Kita ada dua link basically, downlink and uplink. So in TDD, we have to separate the uplink and downlink through the time. So mungkin dekat sini kita transmit downlink, and then dekat satu masa kita transmit uplink. And then kita transmit lagi downlink, then uplink, something like that lah. So kalau FDD, you ada dua, FDD means frequency division duplex. You ada dua frekuensi terus. Satu spektrum ni, satu frekuensi ni memang untuk downlink saja. Satu spektrum lagi untuk uplink sahaja. So that one kita guna banyak lagi spektrum. Tapi tak ada ni lah, tak ada, you don't have to wait for that for the cycle. So untuk kita buat decoupling, kita ada buat downlink ni in C-band, and then uplink ni maybe dekat dengan lower or sub 3G spectrum, 700 or something, so that you can enhance your coverage, a wider coverage with this one. Sebab downlink you, uplink you is not limited by C-band, uplink you is now on sub 3 gig. Okay. Alright. So what is the big plan for 5G? So kita cakap 5G ni, all the technologies, all the people ni. So what actually we can expect? What are the targets for the industry for 5G? So the target is for 5G is to gain maybe 5 to 10 times than 4G. So kita biasa tengok dekat single peak user lah, single user biasa kita dapat dekat LTE ni maybe 200-300 Mbps. Dekat 5G we dapat 1 gig per second. Tapi in actual life kita dapat biasanya dalam 50 LTE. So but in 5G we can get around 500 Mbps, which is 10 times more. And for the set edge user ni means dekat dengan coverage yang tak berapa nak cantik lah. Biasanya dekat Malaysia ni most of the time kita pun coverage kadang-kadang 2 bar, 1 bar, kadang-kadang macam tu. So those speed biasanya LTE around 5 to 10 Mbps. In 5G we can get 100 Mbps, which is quite fast lah. It's enough for now, 10 times. So these are the steps for the expectation. For consumer, we will use the 3.5 GHz, which is the C-band, massive MIMO, plus the sub 3G LTE. So this is to provide both coverage and capacity lah. So the targets we try to get is this one. And for phase 2, we have phase 1 and phase 2 lah. Phase 1 ni macam sini kita cakap target 100 Mbps. It's not immediately lah. So this one in phase 2, the target. So this one is currently for phase 1, we're aiming for this, for the industry. For the users in the home, same, we try to get the average of 500 Mbps. By phase 2, 1 gig per second average. For business, for outdoor coverage is lesser lah. And for more vertical services. So this slide maybe you akan tanya, tadi tunjuk, example tunjuk, tadi tunjuk 5 gig per second. Kenapa dekat sini jadi 1 gig per second? So actually this is, yang ini adalah untuk capability network atau capability that satu antena tu nak transmit at 5 gig per second. Tapi limitation 1 gig per second ni adalah untuk phone kita ni tak mampu nak proses 5 gig per second tu. Hard disk dia pun nanti tak cukup laju untuk copy this throughput. So this 5 gig is the system peak throughput for 100 MHz. Alright. Okay, so that's it about some key technologies or key information on 5G. So let's see, kita dah cakap banyak-banyak ni, more on the global level and more on the what's happening in 5G in the industry as a whole. So what is happening in Malaysia? 5G in Malaysia ni macam mana? Dah sampai mana sekarang ni? Okay, so this one is a slide from MCMC for the Jendela program. Kalau tengok sini, Malaysia right now we are at the DP phase, which is 5G DP, 5G demonstration project. So this project ni for the past few years, I think started 2019 sampai they will try to end it by June. So this is our current phase. So in the demo project ni, it's not, we didn't do a normal demo. Biasanya kita buat new technology, new network, 4G dulu kita just tunjuk buat satu site dan kita tunjuk throughput dia, throughput laju. Tapi in 5G is a bit different because dekat dalam 2G, 3G, 4G kita ada 2C and 2H, to home and to consumer dekat phone je. But in 5G we have 2B. 2B means to business. So when aku tengok kau. Right. Ada soalan ke? Tak ada. So 2B ni to business. To business ni dia bahagi kepada multiple verticals ataupun industry. Kita ada agriculture, education, oil and gas, tourism, smart city. Ada banyaklah verticals. But in Malaysia, what did we do is we do try in 9 verticals. Ada 71 use cases. So use cases ni example, kita cakap example ni lah agriculture. Vertical dia agriculture, tapi dalam agriculture ni ada banyak use cases. Example, automatic sensor or automatic enclosed system. Macam contoh dekat Langkawi, under TM last time, kita ada buat satu container, dekat dalam tu kita boleh tanam pokok, banyak-banyak pokok dalam container tu. So dekat dalam container tu, dia akan control carbon dioksida dia, dia akan control UV light dia akan control temperature, dia akan control humidity ataupun kelembapan dalam tu. so that dekat dalam container tu we can grow pokok yang tak boleh nak grow dekat Malaysia. Example macam sejenis salad yang memang kat Malaysia ni tak boleh grow lah. So normally we have to import, we can grow in the container. So by using sensors and also using IoT, so MMTC, so we can put sensors in each of those plants, not in live, to monitor each of those plant and to make sure it's grow dengan besarnya lah, dengan eloknya. So those are the use cases. So right now in Malaysia 5GDP ni, they shown in Kedah, Perak, Penang, Selangor, maybe Terengganu pun ada. So participated by all these companies lah, DG, Dotco, TM, Maxis, all the big players are there. Even government also joined this demo project because they want to explore the verticals, the new possibilities in 5G. All right. So this 5G is, but right now if you listen to the news, in Malaysia 5G they establish or they open up a new department or a new company called Digital National Berhad. So this company will be doing the 5G for Malaysia. This is the news that they say maybe around end of the year or early next year they will start to deploy 5G. So for those who plan to buy 5G phone, if you can wait next year lah. Jangan beli awal lagi. Tengok dulu dia punya macam mana. Alright. So next one is just to show you the comparison or the gain that we see in 5G. So macam tadi, this actually some testing that we did in Langkawi, in also in KL. So 5G ni in versus 4G, tadi kita cakap pasal bandwidth dia, sebab 5G ni guna 3.5 GHz and 4G tak boleh pakai 3.5 GHz, so kita ada 10 times better experience. Sebab apa? Sebab dia punya bandwidth ataupun jalan dia tu dah besar. Tapi macam mana pula comparison dia tu kalau example jalan dia sama size. So contoh, kita ambil contoh sini 700 MHz lah. Jalan dia sama size 20 MHz LTE versus 20 MHz 5G. Tapi in 5G ni apa dia punya throughput kita boleh dapat compared to 4G. So from theoretically kita boleh dapat around 20% downlink throughput improvement in 5G. So why ni with the same throughput, with the same bandwidth, we can get higher throughput. Example, in 5G we can get around 235 megabit per second. In LTE we can only get 195 megabit per second. So even with the same amount of bandwidth, we can gain 20% improvement in 5G. How did this happen? So it's more to the efficiency of 5G in their codec or in the coding. So the modulation also more efficient in 5G. So that's why we can gain the 20% improvement. So this is the theoretical value, and we tested in a site. Roughly we can get about the same result lah. 5G is better than 4G. So this is just a sharing of the actual implementation that we did in Langkawi. All right, with that, I conclude my presentation for this morning. Pass back over to Cik Faizal, Dr. Faizal.
All right, thank you, Mr. Marwan. Okay, for the great sharing sessions about 5Gs. Okay, so saya open lah pada pelajar jika ada apa-apa soalan. Okay, mungkin para pelajar ni tahu 5G ni mungkin ramai dah beli handphone 5G ni, saya tengok sebab ramai dah banyak company keluar handphone 5G ni. Okay, tapi tahu tak berkenaan dengan 5G. So kalau nak tanya lebih lanjut mungkin boleh tanyakan soalan. Okay, saya buka kepada sesiapa. Kalau nak tanya, tolong buka ni lah, buka mikrofon. Okay, dan kalau boleh buka mic lah, buka kamera. Okay, silakan. Ada soalan daripada para pelajar?
Ada soalan nanti Dr. Faizal tanya soalan dekat dia orang ni.
Itulah, kalau tak ada soalan nanti saya tanya soalan balik nanti pada dia orang. Okay. Tak ada, saya tanya dulu lah. Mungkin teknologi 5G ni, okay, sebab kita tahu 5G ni memang di global memang sedang giat dibangunkan, okay. Dari segi securities, okay, dari segi pelaksanaan, macam mana keadaan, adakah ianya lebih, sebab kalau kita lihat 5G ni knowledge dia adalah dia connect dengan banyak device, okay. So macam mana dari securities tu, mungkin Cik Mimo boleh share dari segi umum lah, okay.
Okay. Security ni kalau kita compare 5G dengan Wi-Fi biasa kita pakai dekat rumah. Wi-Fi bukan communication fix tu, Wi-Fi dekat hujung tu. So Wi-Fi ni lebih open, anyone can sense, packet sense and decrypt. Tapi untuk mobile network, kenapa kita kena bayar the service to every month? Kalau Wi-Fi tu macam is a free spectrum, and one thing for mobile network, using the spectrum yang memang spesifik untuk mobile, and the encryption tu dia adalah daripada hujung ke hujung sampai daripada, let's say, daripada tower tu sampai ke dia punya core network sampai ke internet is encrypted. So macam example, contoh sekarang lah, even in 2G, 3G, 4G pun kita pakai phone, kita buat call, kita buat hantar SMS, kita pakai kita browse internet. So you cannot actually, the operators sebenarnya tak nampak pun apa you buat. You cakap apa, example, Dr. Faizal maybe call ajak kawan pergi main badminton, tapi cakap dekat wife mungkin pergi buat kerja. Sebenarnya pergi main badminton. So dia sebenarnya orang tak tahu pun. So the encryption is there. So as we advance every day, the encryption is getting stronger and stronger. Kita pakai lagi banyak key, kita lagi pakai banyak dia punya coding key tu lagi banyak. So the certificate tu lagi detail, so lagi secure lah. So in terms of security, actually it's not a major concern. I think most of the concern tu kita hear from US on Huawei lah example. So those are the security issues yang diorang highlight. Actually, whatever Huawei can see is similar to whatever Ericsson, Nokia, and ZTE, everyone else, the equipment manufacturer can see. It's just those information. To decrypt that is not something ni lah. Unless you're talking about spy level tu, then that is, if you see ada orang yang hackers, they will say it's easier to hack the person rather than the technology. So lagi senang kita nak tipu orang tu to get information rather than kita try to hack the technology. So they call it social hacking.
Okay. Terima kasih Cik Muhammad. Okay. So kalau kata apa nak scam orang tu lebih mudah, tu memang betul lah tu.
Scam orang memang mudah.
Okay, ada soalan lain? Ada nak kemukakan? Saya dapat satu mesej ni. Okay. Dia tanyalah, okay, kalau kat Malaysia ni, kalau kita lihat sebelum ni ada Menteri Komunikasi katakan Malaysia dah sampai 91% 4G connectivity. Okay. Jadi adakah dengan adanya 5G ni, adakah dia akan overlap 4G ataupun dia sebenarnya adalah satu penambahbaikan? Okay, dan satu lagi mungkin adakah dengan cara meluaskan 4G ni di kawasan-kawasan kampung, di kawasan-kawasan pedalaman, kos dia lebih tinggi berbanding kita nak introduce 5G ni? Mungkin diorang nampak kita perlukan 4G ni lebih penting, okay, berbanding 5G. Okay, boleh?
Okay. So dia punya sekarang ni sebab ramai user dekat dalam network, tak kira lah mana-mana network, mostly dah pakai either 3G phone or 4G phone. So kalau data laju ni is 4G lah. So bila kenapa dia fokus on 4G ni is user dah ramai, and then you can deploy these sites. What is important for the users or the network is site tu. Tower-tower komunikasi yang you guys see dekat dengan atas bukit lah, dekat tepi jalan lah. Those are the key important thing. So you have to have the site dengan dia punya transmission ke internet tu, belakang tu mungkin dia akan pakai fiber lah. Dekat ujung tu dia ada site. Those are important. So even if you deploy 4G, you focus on 4G, but if you want to change it to 5G, it's just a matter of software aja sebenarnya. So the equipment itself dekat site tu capable of 5G. So if they say they expand 4G now, maybe later on they can just switch it to 5G. It's no issue. So the cost tu biasalah, dia sebenarnya cost nak deploy satu site tu almost the same dekat mana-mana. Cuma dia punya berbaloi ke tak tu. So let's say dekat atas bukit sana tu ada seorang je duduk. Nak buat site satu tu untuk seorang tu berbaloi ke tak. So that's another thing lah. So that's why they try to right now they try to do the what you call that SPV ataupun DMB yang saya cakap tadi tu. They try to share, or even right now government dia ada inisiatif dia sendiri yang USP dia panggil, USP fund, meaning government bagi duit untuk operator untuk buat site dekat kawasan-kawasan rural, kampung-kampung. So site tu pula bukannya macam Maxis buat satu, DG buat satu, Celcom buat satu. Tak, dia akan guna satu site dan dia akan share between the operators. Sebab user tak ramai kan, ada berapa je, tapi dia nak provide coverage. They share site tu, they share the equipment, but they are transmitting their own signal lah. So that's how you reduce the cost. Tadi ada soalan on the cost kan. So the cost actually you can reduce by sharing. So this is what the government try to do with 5G. SPV tu, before this, contoh satu taman baru buka, semua orang kena pergi buat site. Celcom kena pergi, DG kena pergi. Sebab tu kadang-kadang you tengok phone you, Celcom kuat sini, kenapa DG tak ada? Kenapa Maxis kuat tapi you mobile tu tak ada? So dengan sharing, with sharing you just buat satu site and then you share among the operators. So it's more level lah, more fair for all. Cuma dia punya offering to the customer tu nanti akan membezakan mereka lah, supposedly. Tapi the cost tu kita dapat jimat dengan sharing. So the cost penjimatan tu we can actually pass it down to the users. Lagi monthly subscription murah. And for 5G ni, I forgot to mention, ada soalan juga yang soalan sama tadi. 5G ni actually dia punya power consumption dia lagi tinggi. So power consumption lagi tinggi, tak logik lah kalau everyone want to deploy the same method as last time. Masa 4G tu semua orang nak buat satu, power bayar mahal lah. And dia power pun guna banyak. So better for sharing. So that's how you reduce the cost.
Okay. So sebab kalau kita lihat di kampus Paguh kan, kita nampak ada satu tower saja. Okay. So itu mungkin adalah yang bahagian SPV lah yang macam Cik Marwan berkaitan tadi. Okay, ada soalan lagi satu kalau di bahagian chat ni, 5G ni akan digunakan dalam bidang perubatan, adakah ia berbahaya kepada badan manusia? So ini mungkin Cik Marwan dah beritahu tadi lah yang bahagian non-ionized dan ionized. Okay, so mungkin saya akan juga dalam chapter antena juga biasanya saya akan terangkan lah, okay, dari segi bahayanya pada manusia ni. Okay, sebenarnya tidak dia tidak bahaya. Okay, satu lagi ni salah, kenapa telco di Malaysia menghadkan penggunaan mobile data, sebagai contoh unlimited tapi ada speed limit. Itu mungkin Cik Marwan ada pengalaman di telco.
Okay, ini memang masalah. Sebenarnya masalah dia ni memang masalah harian lah untuk operator. Kita nak bagi, we try to give the best untuk users, tapi macam biasalah ada yang abuse, ada yang yalah kita bagi unlimited, lepas tu kita tak limitkan speed, ada yang guna download torrent lah apa sampai bergig-gig. So that's one of the reason. And also the limitation tu comes with the price that you pay. Example, package operators, they try to give you the best price, the best package yang dia boleh bagi. Sekarang ni sampai I dengar itu you mobile RM44 unlimited. Dulu kalau kita tengok zaman dulu, just few years back, kita nak dapat unlimited tu almost tak ada lah, semua mesti ada kuota. Sebab apa dia nak ada kuota? Kenapa dia buat kuota? Because dia nak everyone to use everyone have access to the network but not abusing it. So sebab limitation macam saya kata tadi, spectrum ni is very limited. Dia ada throughput, example satu site tu kita boleh katakan 200 Mbps. So 200 Mbps ni nak kena share dengan ramai orang. So bukannya macam example 200 Mbps ni all the time. So nak kena share. So kalau we don't limit this or we don't have a quota ataupun apa, that one person yang abusive or it's not fair for everyone. That's why they call it a fair usage policy, to make it fair for everyone. And while at the same time we try to reduce the cost as much as possible. And that's why they come up with a limited plan with a cap.
Okay, so of course lah, sebab kadang-kadang dari segi apa ni iklan tu kalau keliru tu itu bukan dari segi pihak teknikal lah, itu dari segi apa orang kata undang-undang. Okay, so mungkin boleh utarakan. So ada soalan nak bertanya dalam ni? Saya open.
Assalamualaikum.
Salam. Siapa? Okay, silakan nama.
My name is Eddie.
Eddie.
I'm from Center of Diploma Studies. Okay, I have one question about network and cyber securities. Okay, as we know that in 5G they will introduce some sort of new technology which is like private networks and also virtual 5G core and private network slicing and also IoT connections. Since this is a new technology that will be introduced in 5G, how we are prepared to encounter these new threats, new cyber attack threats. And also, since, as we know, the 5G is more to, 5G network core is more to virtualization, which means it's not stored in the center of the, it's not stored in the center, but it's quite stored your data or your information on the surface only. So how we prepare ourselves from the attack of this new kind of cyber security attack? That's it.
Okay. I think this is a two-part question. First kali kita boleh tackle on the private LTE or private 5G network. The private network ni actually in 4G pun dah ada, in 3G pun ada. It depends. Private network ni, which level of private network the customer wants to go for. Example, police, ambulance, all this, last time they used Tetra network. But then private network, you can either have a physical private network, which means daripada hujung base station pakai transmission sendiri, and also sampai core network pun dia punya core network sendiri. So that's a full private network. But there's some cases where they use in 5G they're introducing slicing. Slicing is using the same secure network, using the same network with the conventional one, with the commercial, but they create a virtual link or a virtual network within that physical network. So this one actually in current situation, we also have already technology we call MOCN, multiple operator core network, and also multiple operator radio access network. So these are types of sharing that can be used for private network as well. But the slicing portion, it really depends on the decryption and also the encryption and the securities too should be on par with the current MOCN and everything. So the technology is there. The slicing to more on the automation of creating this private network automatically and smoothly. So, and then the second question is on the virtualization of the core network. So actually right now, everything, the core network, the traditional core network is also actually in a server or in a, or what you call it, in a cabinet servers rack. So the core network portion, the function is actually inside the server. Server ni macam PC lah, it's a blade server banyak-banyak, then it's a part inside the function in there. So virtualization is you can use a normal server rather than a what you call that, a specified build server, a normal server for to host the same function. So the security or in this virtualization is the same as before. The security layer, the firewall and everything is being implemented as part of the virtualization. So it can be containerized into multiple functions. This is banyaklah right now, many ways to do lah, whether they use it containers or VMs or something like that. There's also types of core network, they call it cloud core. So cloud core ni means being stored in the cloud somewhere, maybe in a data center somewhere in Japan ke apa ke, tapi network dekat Malaysia. So this one is normally offered by some of the vendors, but I would say the security is there. The security is there, but physically it's far away. So for peace of mind, biasanya, if depends on the requirements on the customer or the level of security that you need. If you deal with financial transaction and everything, normally banks, they have their own servers, everything inside their own building. They don't even put in the data center. Depends on the level of security that you need. Sebab the highest level security and the cost will be higher. So that's how it is. All right. Hope that answers your question.
Yeah. When you talk about that, when the network is here and the server is somewhere else, so something I experienced in the UK, which is most of UK customer service is in India. So whenever you want to call the customer service, you will call the customer representative, which is we will talk in Indian. With Indian dialect, it's such a difficult. You will face difficulties when you talk with them. So it's just want to let students know, even though UK is I think this developed country, they still use the I think third country people since it's more cheaper. I think that the main concern is cost. That's why they use the Indian technologies rather than UK itself.
Yeah.
Okay.
Actually, that one I can agree with that. And also, we are very connected right now. So macam sekarang ni, I'm in Nilai Johor. Nilai Johor pula. Nilai Negeri Sembilan. And you guys are in Johor. Most of you guys in Johor. So we are having meetings here, like we are face to face. So of course, the companies and the industry make use of this and try to find a more cost-efficient way to do works. It's not just in the customer service department, maybe in the industry as well. So sometimes you see people go present something with engaging with the customers is the front end, but at their back end is not necessarily in Malaysia or in that same country. It can be from anywhere. Same with the technology, not to say good countries, then you have some backup from other countries, Can be also in Malaysia, there's some technologies with some experts that are supporting us remotely from maybe Australia, from maybe Europe. Is a common thing to work because expertise is everywhere in the world right now, and you can get connected very easily. All right.
Okay, thanks Mr. Marwan. Okay, and Mr. Eddie for question. Alright, so kalau kita lihat di bahagian chat tu ada banyak question tapi masa telah menceburi sekarang dah pukul 10.20. Okay, hopefully nanti saya akan soalan-soalan ni saya akan maybe secara personal dengan Encik Ahmad Marwan, dan mungkin saya akan maklumkan kepada semua pelajar lah. Okay, sebab masa sekarang kita target sampai 10 suku. Okay, sebab lepas ni ada beberapa orang pelajar akan ada kelas yang lain lah. Okay, so saya rasa untuk kita punya sesi ini adalah sampai sini sahaja. Okay, terima kasih kepada Encik Ahmad Marwan, okay, atas perkongsian tentang teknologi 5G. Okay, saya nampak there is a lot of views. Okay, pelajar pun dah nampak apa yang ada terdapatnya dalam 5G ni, apa views kepada teknologi di Malaysia, apa aplikasi dia. Okay, so dah nampak. So hopefully mungkin saya satu nak mungkin kata-kata akhir lah pada Cik Marwan tentang expectation dalam bidang telekomunikasi ni, sama ada di Malaysia ataupun di luar ataupun di peringkat global lah. Mungkin sebab pelajar ni lepas ni akan sambung ke degree, mungkin akan lihat kepada dalam bidang telekomunikasi, untuk bekerja dalam bidang telekomunikasi. Dan mungkin Cik Marwan boleh share lah apa kelebihan ataupun apa yang mungkin boleh membuka minda para pelajar ni dalam bidang telekomunikasi ni, dan juga kata-kata akhir lah.
Okay. In telekomunikasi, in the industry, telekomunikasi ni is very fun lah for me. Sebab you're dealing with internet, and internet is everyone is using. So semua orang pakai internet, and your team ataupun your experience kadang-kadang tu not just limited to Malaysia. You have to work dengan orang-orang globally, and you have to know apa yang berlaku kat dunia ni as a global, what are people doing. And also sometimes yalah dealing, pergi overseas ke, pergi travel ke, and the work is very rewarding lah. You can see very rewarding in the sense of you help someone. So example kita ambil pandemik ni lah. So in last year bila ada pandemik, dia buka quarantine center, and then buka quarantine center, ramai orang kat sana. So internet tak cukup. Even macam I mention tadi, 4G pun dia ada limited bandwidth apa semua. So we do and open up 5G in MIAPS to provide internet to the patients. So you can see people are having fun, buat TikTok, nari-nari lah dekat dalam MIAPS tu. So I think you feel that you are doing something for your community as well. Without communication, without telecommunication, I mean kita will not advance as a human race up to this level. And lastly, I would like to say thank you to Dr. Faizal for inviting me to give this session, and I hope the students and everyone can gain something lah from my small sharing. And if any mistake, salah silap tu biasalah, minta maaf. Baik tu daripada Allah saja. Silap tu daripada saya.
Alright, okay, thank you Cik Marwan. So lastly, mungkin boleh untuk kita ambil sesi bergambar. So kalau mana-mana pelajar boleh buka kamera, okay, untuk kita ada sesi bergambar. Okay, sesi bergambar secara maya je lah. Okay.
Advance sekarang.
So kita dah jimat masa dah kat situ. Okay, buka dulu. Oh, Cik Zarin pun ada. Okay, kita punya ketua jabatan pun ada di sini. Alright. Okay. Okay, first smiles. Oh, sekejap 4, 5, 6. Okay, so okay, smiles. Okay. Ini sebenarnya untuk kita bukti kehadiran jugalah. Okey, Cik Marwan ni dia sebenarnya sahabat saya lah, sahabat saya daripada saya zaman belajar. Okey, dia memang expert lah daripada kami dalam bidang telco ni. Okey, so insyaAllah insyaAllah jika ada apa-apa taklimat ke ataupun yang share session untuk dalam bidang telco ni, insyaAllah kita akan bekerjasama semula dengan Cik Marwan. Okey, so daripada saya itu saja. Okey, terima kasih pada para pelajar. Okey, so ada beberapa orang kata buah tangan lah, ataupun ada macam soalan-soalan sikitlah, soalan-soalan simple yang dah di-share kepada para pelajar. Okey, so hopefully para pelajar dapat lakukan. Okey, dan untuk Cik Marwan, okey, Cik Marwan terima kasih banyak atas sharing session di sini. Okey, hopefully jangan seriklah. Okey, jika mendapat invitation lagi daripada kami. Okay. So sebabnya banyak lepas ni mungkin 5G, mungkin tahun depan akan ada 6G dan seterusnya. Okay, kita mana tahu kan. Sebab okay, so terima kasih kepada pelajar kerana sebab ni ada beberapa pelajar yang akan ada hadir ke kelas, okay, secara online juga. Okay, so daripada saya itu saja. Terima kasih kepada Encik Marwan, kepada ketua jabatan, kepada staf JKE dan juga para pelajar yang dikasihi sekalian lah. Okey, terima kasih dan semoga kita bertemu lagi. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Terima kasih
Terima
Tuan.
kasih. Assalamualaikum.
Tuan. Terima kasih.
Terima kasih Tuan.
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 Tuan.
Okey, sama-sama.
Terima kasih Tuan.
Terima kasih Tuan. Terima kasih Tuan.
Terima kasih Tuan.
Bersama jaga untuk COVID. Dah masuk kampus ke, doktor?
Tak payah doktor-doktor sangat orang.
Ya.
Dengan pelajaran sekarang ni, pelajaran ni memang ada di kampus lah. Okay? Kalau kita ada yang gambar video tu, ada yang dalam kampus. Okay?
Kelas lah.
Dia orang masuk pada sebulan lepas. Okay? Dia orang masuk dan kemudian kena kuarantin 14 hari. Okay? Dan lepas tu baru dia orang ada yang face to face akan ada online jugalah. So kita panggil sebagai hybrid lah. Okay? So yalah, okay, kalau online ni biasalah kan, okay, ada banyak limitation juga, okay. Mungkin boleh pasang 5G kat UTHM ni, boleh apply ni.
Boleh apply. Diorang pasang lah tu. Okay.
Okay, terima kasih Muhammad.
Okay, jumpa lagi.
Okay, jumpa lagi. Assalamualaikum.
Salam.